The numerical is a variable w is related to three other variables x, y, z as w is equals to xy by z. The variables are measured with meters of accuracy plus minus 0.5% reading, plus minus 1% of full scale value and plus minus 1.5% reading. The actual readings of the 3 meters are 80, 20 and 50, with 100 being the full scale value for all three. The maximum limiting error in the measurement of W will be. This question is asked in GATE 2006 and here are the options. In this numerical, what is asking? That is nothing but the limiting error. So, how will you find the limiting error? Let us suppose if one function is given, let us suppose that is a function is given. When we find out the error, that is the simple error, then it is denoted by delta a. And if we have to find out the limiting error, in that case it will be denoted by delta a by a. These are the notifications for simple error and for limiting error. Now, before solving this numerical, let us see how will you solve this numerical stepwise. What are the steps we have to follow it. So for that, consider one example. Here we are taking one function, that is the capital X, which is the product of x1 and x2. So for finding the limiting error, first we have to take the log on both the sides. So take the log on both the sides. So what is the equation becomes? Log x is equals to log x1 plus log x2. Now differentiate with respect to capital X. So you will get the equation 1 by x is equals to 1 upon x1 dx1 upon dx plus 1 upon x2 dx2 upon dx. So from this right hand side, take dx as the common and shift to the left hand side. So what will be the equation becomes now? Dx by x, forget this plus minus sign. Now the equation becomes dx1 by x1 plus dx2 by x2. From where this plus minus sign occur? We have know that here it is always plus minus the error and here is also the plus minus sign is there. So from this equation, if we take plus minus as the common, then in the bracket the remaining sign is nothing but the plus sign. Here minus sign will not be present in the bracket, because when we solve it you will see that here when we take the plus minus as the common from this equation, then in the bracket only sign remaining is the plus sign. So you can see here dx by x, that is nothing but the limiting error. We are denoting limiting error as dx by x, or you can say del x by x, anything. So this represents the limiting error for the function, that is the x function. So in this way we have to find out the limiting error. That means first of all we have to take the log on both the sides, then differentiate with the main function and take the common, and after solving the equations you will get the limiting error. Now remember all these steps and now see the given numerical. This is the given numerical. In this numerical, what is the function is given? That is w is equals to xy by z. This is the given function and some data is given, that is accuracy is given for all the 3 meters and the actual readings is given. Actual readings is nothing but the true values. This actual reading is nothing but the true values. This the true values for all the 3 meters are given and accuracy is given. So what is the purpose of this accuracy? I told you afterwards. So first of all, given function is there, that is w is equals to xy by z, and actual readings that are nothing but the true values or the true readings of the meter are given, that is 80, 20 and 50 for x, y and z, and the full scale value is given for all the three. For all the 3 meters, the full scale value is same, that is the 100. So the full scale value is given, that is 100, and again we have to find out the limiting error for w. Clear? So given data first of all, after that the function. function is w is equals to xy by z. Now we have to find out the limiting error. That means which step we have to follow. That is, first of all, take the log on both the sides. So first step, take the log on both the sides. So equation becomes log w is equals to log x plus log y minus log z. Why it is minus? Because when it is in division form, the sign is coming, when we take the log, the sign we are using, that is nothing but the minus sign. When the multiplication is there, in that case, the sign is always positive when we take the logs. So here, this is the equation by taking the logs. Now the next step will be differentiate with respect to w. Now differentiate with respect to w. So equation becomes 1 upon w is equals to 1 by x del x by del w plus 1 by y del y by del w minus 1 by z del z by del w. In this equation again, take del w as the common and shift to the left hand side. So the equation becomes del w by w is equals to del x by x plus del y by y minus del z by z. Let us suppose this equation will be your equation number 1. Now in this equation you can see that this is del w by w is nothing but the limiting error. Here this del w by w, it will represent the limiting error of w. So in this equation, what are the unknowns are here? Here the unknowns will be del x, del y and del z. These are the unknowns. What is this x, y and z values? It is given, that are nothing but the true values. So true values for x, y and z are already given. We have to find out del x, del y and del z. So how will you find out these three quantities? For that, accuracy is given. Accuracy is equals to the percentage error. So error is denoted by delta. So for x, it is denoted by delta x. So for delta x, accuracy is given, that is plus minus 0.5% of reading. This is the accuracy is given. So here substitute the values here. Plus minus 0.5%, that means 0.5 divided by 100 of the reading. Reading for x is 80. So substitute the values, you will get as plus minus 0.4. Similarly, we can find out for del y. For del y, what is the condition is given? That is plus minus 1% of full scale value. So here full scale value will be 100. It is already given in the numerical. Now substitute the values. Plus minus 1% means 1 upon 100. Full scale value, that is 100. Substitute the values, you will get plus minus 1. Similarly, go for the del z. For del z, condition is given, that is plus minus 1.5% of reading. So substitute the values here. 1.5% means 1.5 divided by 100. And the reading for z is 50. It is already given. After substituting, we will get plus minus 0.75. These are the three quantities which are unknown. Okay, that is del x, del y and del z. And now we are finding all these three quantities. Now in equation 1, substitute all the values. That is del x value, del y, del z, and we know the x, y and z quantities. From this equation, when we substitute all the values, we have to take plus minus sign as common. So in the bracket, remaining sign is only the plus sign. Always remember that. Multiplied by 100, that is for the percentage. Clear? Now substitute all the values and find the value that is coming out to be plus minus 7%. Is it clear? That is del w by w, that are nothing but the limiting error of w. The limiting error for w, that is plus minus 7%. Now from the options, the option D is the correct option, that is plus minus 7% reading. That is the limiting error of w. Limiting error of w is coming out to be plus minus 7% reading.